Thank you. Yep, my name's Kurt. I work for Terabase on the PlantPredict product. I'm going to start off this talk with a bunch of caveats. I'm brand new to the team. This is my official 3rd month at Terabase. And I want to also say that a lot of this work is based off of people who are much smarter than me and who came before me. Okay, so I'm gonna kind of back up from just throwing out all of the features that we've been working on and kind of take a 10,000-foot view of what a solar performance modeling tool is and, why we might need more than one. So we'll start with what is PlantPredict, then I'll throw all the new features out at you, and then we'll talk about some stuff that we're working on. So what is PlantPredict? First, I kind of want to talk about what I think of as what is the ideal performance modeling tool. And I think it's a blend of 3 factors. Capability being one of them, ease of use being another, and transparency being the third. I think PVLib, for example, open source code, does an amazing job at transparency, does an amazing job of making us more capable as PV performance engineers. Might not be the easiest to use if you're not familiar with Python. That's one example. PV watts might be really easy to use, might not have all of the fine-tuned capability that you might want to have in a performance model, but it's all based off of PVLib and SAM. Everything's open source. It's highly, highly transparent. You could do some custom software development and you can get anything you want done, but none of us are going to know how it works. And that's hard to do. I think PlantPredict is kind of a blend of all of these things. I think we've focused quite a bit on the ease of use portion. We're working quite a bit on transparency, and we're looking to increase the capabilities. And with each new feature that I present, I'll hopefully show that we're thinking about all 3 of these things in everything that we do. Okay, so what is PlantPredict? It's a cloud-based performance model. It's database backed. We have prediction engine versions, which means that, let's say we came out with version 10, we come out with version 11, you think, wow, Kurt is a horrible performance modeler. I don't trust him. I want to stay on performance 10. You're absolutely allowed to do that. We have regression testing. So every single time we put out a new update, we put out a new update every 2 weeks, we run a set of 600 regression tests and make sure we haven't broken anything in our performance engine. We have an API and an SDK, so it should make it very easy for you to run optimizations if you want to run a ton of models all at once. I think it's quite easy to do that in our software. I was talking to a performance engineer today, and I was asking them what they thought of our UI, and they said, I don't know, I've never used your UI. They've only used our SDK, and I thought that was really cool. We're a GIS-enabled tool. I'll get to that in a second. I think that a lot of the presentations and posters here have sort of focused on hourly modeling correction as the way to model the effects of sub-hourly. We can take any time step down to the minute. So whatever your input weather data is, we'll take it, we'll model it natively. We're third-party validated, and Terabase is building an ecosystem around PlantPredict. PlantPredict is the core of what we do, and then we'll build a set of pro apps around PlantPredict. Okay, so here's a picture of our UI, if you've never seen it before. It's just showing, I think this is 5-minute data. We'll take it, we'll model it. No need to do hourly modeling corrections. I'm trying to click. This is what I was talking about with the prediction engine versions. If you, let's say, have a contract that's riding on version 10, just because we've upgraded to version 11 doesn't mean you have to come with us on version 11. We have validation reports. Here's some of our API documentation. I think some people get confused between an API and an SDK. The SDK is just like a Python wrapper around our API, makes it really easy for you to interact with PlantPredict in a very Pythonic way. So if you feel comfortable with Python, you should feel comfortable also talking to PlantPredict. A lot of our users use PlantPredict just for this feature alone. We're GIS enabled. So what that means is you can draw polygons and we'll hit all of these different GIS layers. We'll create constraints for you, and we'll let you know what your capacity is. Some people even take this feature and let their developers run with it, which is dangerous, but can maybe save some of the time of them coming to you and asking you how much capacity does this land fit. Here's our ecosystem. We have a Voltage Pro app, which tells you how many modules you can fit in a string. It's based on simulation rather than ArrayTree. And Jason Spokes is here. Jason, if you want to raise your hand, he's the product owner on this tool. And please, you can go to him if you have any questions. So, time to spew new features. We now have circumsolar allocation. We're following PVSys here. Now you can change your circumsolar allocation from the diffuse part to the direct part. We wanted to make sure we knew which one was the right one to do, so we asked ChatGPT. And it's the beam, so that's the end of the debate there. We implemented the Sandia inverter model. Previously, we had a bilinear interpolation model, which was under predicting inverter performance at the lower ends of the curve. This says it's planned, but it's done. I didn't update my presentation. Basically, we implemented diffuse irradiance optimization. There's a issue if you only take the ideal case where at every single time step, you're pointing your PV modules at the most optimal angle that you could possibly be at, because trackers in real life are non-ideal. And so we added 2 parameters to this model. We added the tracker rotation speed, and we added a hesitation factor because a tracker might not see a diffuse irradiance and immediately decide this, now I need to move. I need to start moving. Maybe you're thinking that because the tracker being at a diffuse position and then having a miss, as in your should be at a direct position, your loss is so asymmetric there. You might want to have a hesitation for your tracker model. This is a really hard problem, especially to do generically, because each tracker manufacturer is thinking about this differently. You know, one of them might be using a forecast to decide. One of them might be using a pyranometer and a decomposition model. Someone might be using an all-sky camera. Different tracker manufacturers operate at different time steps. So they're sending commands from their like zone controller to their row controller every 5 minutes, every 15 minutes. But there's a discussion on the Google group, and I think it's really interesting. If you're interested in that, please follow along. We implemented 3-hour rolling average ISC. Should help with some string sizing calculations. We implemented PVGS Horizon API, make it easier to use so you don't have to go and grab it on your own. We implemented an entirely new documentation area. This one is searchable, which is nice. Searchable documentation is good. And we have started to make references to PVLib and also the specific implementations of the model from PVLib. PlantPredict is a C# program, but we couldn't do what we do without PVLib, and we're incredibly grateful for that library. Talking about usability, we also implemented what's called the Bang Wang color palette. And so this is within a new area called accessibility options. This should hopefully help people with some types of color blindness use our tool and charts easier. Upcoming, we want to engage with our community a little bit more. So we're going to put a feature request, kind of like with Slido, where you can ask something and other people can upvote it. We're going to implement feature requests so we can hear what you want from us. And we're going to implement a new 3D shade model. Currently in PlantPredict, you know that basically the shade model is implemented at the block level. And so each block has its own separate 3D shade scene, and we're going to combine them all into one global plant 3D shade scene. And that's it. Thank you.